Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing exponential functions. This is standard A.9D in the great state of Texas, and we are using item number 20 of the 2022 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have an exponential function here. The giveaway is that to the x power up there, we need to find the y-intercept. So we've got options, right? If we want to, we could plug this into our graphing calculator. We could trace it. We could find the y-intercept, but we can actually figure this out without doing any of that. So let's make sure we understand what an exponential function is and what each of these terms mean. Here's our standard form. Y equals a times b to the x. So this h of x is serving as our dependent variable. That's our y. 12.3 is our b. 4.9 is our 12.3 is our a. 4.9 is our b. And then your x is your x. Right? So it matches up. It looks like it should. What is this a term? Well, this a term is going to be multiple things. If we are dealing with compound interest, right, we are saving money, and you have an annual interest rate that's compounded, it's 12% or something like that, right? It all depends on your principal, your initial starting deposit. That's what this a term would be in that context. A lot of times we'll get word problems, and we are dealing with population growth, bacterial decay, something like that, and it will always give you an initial amount. How much are you starting with? And then what is the rate at which it's growing or decaying? And then over how many years or weeks or months? But you need that initial amount. So whether you want to call the a term the principal or the initial amount, for our purpose, since we don't have any word problem here, so there's no context, we can also view it as our y-intercept, aka exactly what we are looking for in this problem, since we are looking for the y-intercept. Now, how do we know that the a is the y-intercept? Well, mathematically, it's really simple to prove. The y-intercept is where your function crosses the y-axis, right, when x equals 0, right? Because the y-axis is just a vertical line that represents x equaling 0. So let's plug it in. Let's make this equation x equals 0. I'm going to substitute in my 0 for my x. So now it's a times b to the 0. B to the 0, anything to the 0 becomes 1. No matter how big or small it is, doesn't matter. Anything to the 0 power becomes 1. So now it's a times 1, which is just the identity property of multiplication. Anything times 1 is just itself, which means when x equals 0, y equals a. So that's how we know. And that's really what we're looking for. So what is this b here? This b here is going to be your rate, the rate we were discussing. Now it's a growth rate if it is greater than 1. In this case, it is greater than 1. 4.9 is greater than 1, which means when you are graphing it, it's going to look something like this. Asymptote is always going to be on that x-axis, unless you add something to this equation like a plus 7 or a minus 9. That's how you can shift the whole thing up and down. When you don't have another term being added or subtracted from it, it's just going to be asymptote on that x-axis, and then it's going to move up. It's going to grow up towards the right, which is what this one's going to do. If you have something less than 1, so it's a decimal, it's a fraction, it's going to be a decay rate. And so it's going to be the opposite. It's going to start out really tall and swoop down, still asymptote on that x-axis. And so that's what we need right here. This a term is going to be our y-intercept. So when we bubble this in, remember you have a floating decimal point, right? So we're going to need 12.3 and just bubble in the correct terms. And you don't need to worry about the positive or negative over on the left. You can just leave it blank since it already is positive. And that's your answer.